Hello, my name is Madeline Thompson, and I'll be talking about the paper by David Nadeau and Satoshi Sekine titled A Survey of Named Entity Recognition and Classification. So as a brief overview, I wanted to touch on what are natural language processing, or NLP, and information extraction. These are two key topics that we'll be talking about from this paper. So, natural language processing, or NLP, is when you use a computer's algorithm to extract meaning from unstructured text or natural language. Information extraction, or IE, is when you automatically extract structured information from unstructured or semi-structured documents. So you can think about how, a natural language or an unstructured document might be something like an article, a book, a blog post, etc., something where a human could easily read that and extract the meaning or the information required from that text, but a computer might not be able to do that so well. So in the early 90s, the Message Understanding Conference, or the MUC, was actually focusing on extracting company activities and defense-related activities from unstructured text. It's essential to recognize information units like names for this task. So initially they focused on just company names and they used very handcrafted rules. And this early research is heavily funded by DARPA. This is where named entity recognition comes into play. So named entity recognition is the recognition of named entities from unstructured text in the information extraction field. First of all, what is a named entity? So a named entity, it can be one of two things, a name or a numeric expression, as this paper talks about. So a name would be a proper noun, such as a person, organization, or location, and a numeric expression could be something like time, date, money, or a percentage. And like we can see, there's a lot of different ways that you can represent these named entities. For example, you could state time in military time, you could use Pacific Standard Time, etc. You could write the name of a date out, i.e. writing out March. You could also represent an organization in different ways. For example, not all organizations end in incorporated, etc. So a little bit more about named entities. How do you define a name? So there are three types of names that are collectively known as enamics that this paper talks about. So those three items are persons, locations, and organizations. Other named entities include the miscellaneous type, which is anything outside of those three, timex, which is date and time, and numex, which is money and percent. There are also other marginal types such as compounds, structures, etc. So how do you recognize a named entity in text? Early studies, like I mentioned, used handcrafted rules. They came up with the rule that if two words are capitalized, the first letter of each of those words is capitalized, that might be a name put together. Later methods include machine learning, and this paper talks about using supervised learning in order to study named entity examples and design rules to capture instances. Unfortunately, supervised learning requires a lot of annotated text to use and thus is very costly. This paper also talks about semi-supervised and unsupervised learning being the way forward because these require a lot less annotated text in order to run or no annotated text in order to run in the case of unsupervised learning. So NERC systems require two things in order to work. And so those two things are feature space and evaluation metrics. So features allow us to recognize and classify named entities. A feature space would have word level features such as character makeup of words like case, punctuation, numerical value, and special characters. They would also have list lookup features, which represent the is a relationship. So Apple is a company, Jane is a woman, and document and corpus features, which go beyond just a single word and multi-word expressions. They include information about multiple occurrences, syntax, corpus frequency, and more. So that would give you the idea of how often a word like name appears in a text. Evaluation metrics are a way to evaluate how well your system performs with real data, with training data. So these three that the paper mentions are MUC evaluations, which score the system based on its ability to find the correct type and exact text. Exact match systems, which either give points if you match exactly or not, and ACE evaluations, which are a complex evaluation procedure that gives partial points. So we can see here an example of an evaluation from an NERC system. So this evaluation, we can see in the first row, the correct solution. So what the system should have identified is the word unlike. Our system incorrectly hypothesized that there was an entity when there is none. So it incorrectly said that there is a location called unlike. The second row is where there is a person named Robert, and our system completely missed this entity. It did not identify that the name Robert was a person. In the third row, we have a person named John Briggs Jr., and our system incorrectly labeled this as an organization named John Briggs Jr. The fourth row has an organization named Wonderful Stockbrokers Incorporated, and our system incorrectly labeled this as, well, it correctly labeled this as an organization, but it got its boundaries wrong. So it only extracted the word stockbrokers. The fifth row is a location named New York, and our system incorrectly identified this as a person named in New York. So it got the wrong label to the entity and it got its boundary wrong. So you can see how there's different ways that we can score this system based on those three different evaluation metrics we just talked about. So from the conclusion of this paper, there was a really poignant quote that I will repeat to you now. NERC will have a profound impact in our society. NERC systems enable monitoring trends in the huge space of textual media produced every day by organizations, governments, and individuals. This brings to mind the thought of data volume and data velocity. We have a large amount of volume of data coming at us at a very fast velocity, and we want to be able to extract information from that data. So how has this paper contributed to the field? This paper has been cited over 2,000 times since it came out in 2007. It's a very important survey paper in named entity recognition research. And in named entity recognition today, there's a 2016 paper talking about neural network architectures applied to named entity recognition that has a really high success rate. There's also different programs that support NER, such as GATE, OpenNLP, and SPACY. And NER today has really high accuracy, but there's still some domain-specific challenges that remain. So we aren't done with NER. There's still a lot more research to be done on this topic. Some of the domain-specific research that I read about from this paper and from other papers related to named entity recognition are biomedical named entity recognition, or BNER, which aims at extracting biological and chemical names from biomedical texts and is applied in biomedical research, bioinformatics, and genetics. We are also, another topic that is common is applying a named entity recognition to linguistically complex media like Twitter. And this paper mentions different commercial uses such as search engines and more. So overall, the pros and cons of this paper. I thought that this paper was a really good survey paper, included a complete history of named entity recognition and classification and the motivations behind it. And I thought it was really easy to read and understand the information and the different algorithms that were used. However, I think that this paper could have talked a little bit more about future work in the field and potential impacts this work could have. It also didn't spend very much time on specific applications and use cases, and I think it could have done both of these things really easily, and it would have contributed to the overall success and applications of this paper. So here are the paper and some other papers I read on the topic. Thank you so much for watching.